right, what's going on, everybody? We're going to do a second lesson here with imaginary numbers, but we're actually going to, as you can see, kind of step it up, and we're going to call these complex numbers, okay? And what a complex number is a number that is partly real and partly imaginary, okay? And so the standard form for a complex number is something that looks like this, okay? A plus B I. Now, this, in my mind, is going to confuse quite a few students because there's 3 letters here. But really what we're talking about is any of these. These are all complex numbers, right? So let's grab this first one, 3 plus 2i. What this is this is a real part of the number. The 3 is real. And this 2, this is the imaginary part of the number. And so we call this complex because the whole thing is not imaginary. There's only a portion of it that is imaginary. Another thing about complex numbers is that technically every number could be written as a complex number, okay? And so, for example, if I wanted to write the number 7 as a complex number, I would just write 7 plus 0 i's, right? 7 is real, nothing is imaginary, and so technically this is a complex number in complex form. So sometimes you'll get an easy question that's like, write the answer in complex form, and you've got to do something like this. Sometimes you'll have a question, doing the same process with this, you would just write it as 0 real stuff plus 3i. Now the good news is, we always are going to have our answer in complex form on this every single question we do for these notes needs to look like this. A plus B I. A number plus a number that is imaginary, period. And you'll see what I mean when we get down to maybe like questions number 7 or 8 or something like that. So jumping into this really quick. Number 1, we need to add these 2 things together. These are 2 complex numbers. And adding complex numbers is really easy. You're going to add the real stuff together. You're going to add the imaginary stuff together. Obviously, you can't add the fake stuff and the real stuff. Or I guess that's backwards. The real stuff and the fake stuff. And so you can't add these 2 together. You can only add these 2, right? That is a regular old 3 and a regular old 9. And that makes 12. Okay, this is an imaginary 2 and an imaginary 1. And so we add those together, and we get 3i. And that is it. That is the whole thing. That is the whole question. Not any more complicated than that. You're just adding up the regular stuff, adding up the imaginary stuff, and moving on. Number 2. Now, here's what I'm going to tell you. We've got to do addition of these, subtraction of these complex numbers. We're going to have to do some foiling of these complex numbers. And surprisingly enough, subtraction is the hardest out of all 4 of them. It's not actually hard, but it is the one that everyone is going to mess up. And here's what they're going to do wrong, okay? When we subtract these 2, we're going to subtract the 2 real numbers. This is a real 8. This is a real 1. And so when we subtract these 2, we're going to get 7. I'm sure that's no surprise. I'm sure we feel good about this. Here's the issue here. We've got this imaginary piece here. We've got this imaginary piece here. And we need to add these 2 pieces together. But we don't need to add them together. We need to subtract them. And so what ends up happening is people say, well, this is 1 minus 3. But it's not 1 minus 3. It's actually 1 minus a negative 3, okay? We have to use this negative to kind of change the sign of this final number here. And so you have to be very careful. This is actually a 1 minus a negative 3. And minusing a negative is the same thing as adding. And so actually, when we do these 2 things, that would be 4i. A lot of people will look at this and they'll say 1 minus 3, that's negative 2. But they've totally forgotten this additional subtraction in the middle here. When it comes to subtraction, you need to be extra, extra, extra careful, okay? You've got to subtract the 1, and you've got to subtract the negative 3. And so take your time with subtraction. I'm telling you, sorry, that would be a plus. On the test, the subtraction questions are the most missed questions. Even though they're easy, technically, they're still tough to, be organized and remember. All right, number 3. These questions are a piece of cake, especially the addition ones. 8 is a real number, 5 is a real number. You add those two together, you get 13. Then we've got negative I and positive 13i. We can add those two things together. That's basically 12 apples and a negative apple. And so 13 apples and a negative apple, which makes 12. Not good when your math teacher is making mistakes. But there we go. 13 plus 12i, and that is the whole thing. So let's try out another subtraction question. We've got 2 in a row here with number 4 and number 5. Again, it's the first part, pretty much everybody's going to get right. They're going to say 7 minus 3, and they're going to get 4. Okay, that's a piece of cake. It's this second part that a lot of people will make mistakes on. Okay, it's not just 2 plus 3, it's 2 minus 3. So 2 apples minus 3 apples is going to be negative 1 apple. So that would be our answer right there. And let's do one more subtraction question. With this one, again, the first one people pretty much always get right. 5 minus 3 is 2. But the second one is going to mess somebody up. It's got to be I minus negative 8i. So it's I minus negative 8. Subtracting a negative is going to make addition. So we've actually got basically I plus 8i, and so we've got 9i, a positive 9i. It's really not that tricky. It's literally, 3rd, 4th grade math. When you learn about negative numbers, actually maybe you learn about it later than 3rd and 4th grade, but whatever. Whenever you learn about negative numbers, that's all the math we're doing here, but you just have to be careful and sort it out from there. Okay, let's move on. Let's go to number 7. Here we've got distribution. That's going to be very easy. We're going to pretend that this I, it's going to work exactly like X's work, okay? And so if we just, for a second, maybe don't write this, but let me do the question. If we just pretend that this was X's, this would be a super easy question. We would multiply those and we get 3x. We would multiply those and we get x squared. That is literally the exact same process that we're going to do, except for we have i's instead of x's. So we multiply these two and we get 3i. We multiply these two, and we get I squared. Now, we actually have a problem with this answer. Okay, this is not a good enough answer. And the problem is we need to have complex numbers. And that is A plus BI. And right now, we have this, I squared. As you can see over here, there's no I squareds in a complex numbers. So, any ideas what we're going to do? Right. This is where we want to keep in mind that crucial thing, I squared equals negative 1, right? This is a circumstance where we have stayed in the imaginary realm and we've made our way back to the real world, actually. This is actually a real number. So what we need to do is swap this out and change this into a negative 1. And so our answer would look like this. Now, some teachers are going to be picky, and they're going to say that the imaginary part should come second. I don't really care as much, so maybe you want to rearrange this, and maybe you want it to look like negative 1 plus 3i. To put the imaginary stuff second, but these are the same thing. So this answer over here check. This answer over here, check. They're both right. However you want to do it. And so we have these questions where we're going to do them exactly like if the i's were x's plus this additional step. Anytime you get an I squared, you just swap it for a -1. Anytime you get an I squared. So let's do number 8. We're going to go really quickly here. 2i times 6. 2 times 6 is 12, so this would be 12i. Then we've got 2i times I. That would be 2i squared. Again, the I is getting treated exactly like x's. 2x times x would be 2x squared. Okay, now that we've done this, every single question is very, repetitive. Here's an I squared. I squared is not allowed to stick around. I squared has to be changed. So I squared has to get changed to a -1. Now, what we're going to have is 2 times I squared. That's going to turn into 2 times -1. And so this is going to become -2. Okay, now it's still just a -1, but we basically are skipping a little step here where this becomes 2 times -1, and that becomes -2. Okay, your I squared will take whatever number you have and it will just turn it negative because I squared is a -1. So final answer, 12i minus 2. Or if your teacher's picky, maybe you need to do -2 plus 12i. But it's all the same thing. And let's do a couple foiling questions here. Now, foiling is a few more steps, but we're going to do the exact same process as we've done before. We've got 1 times 2. That's going to be 2. Then we're going to go ahead and do 1 times I. That's just going to be I. Then we're going to go ahead and do 4i times 2. That's going to be 8i. And then we're going to do 4i times another I. And I times I is going to make I squared. And so we're going to get 4i squared. Now, these questions are very, very repetitive when it comes to these foiling questions. These middle two numbers that are both regular old i's, they can be combined together. I plus 8i is going to be 9i. And you're pretty much always going to have an I squared that you're going to need to swap out as well. And when you swap this out, remember, it's basically just going to take whatever number you have and turn it negative, because this is like 4 times -1, and that is like -4. So we're going to go ahead and we're going to swap this out for -4. We still need to hold on to this 2 that's over here. And so we've combined the middle two, we've sorted out the I squared, and then we have one more step. These two pieces are now back in real number terms, okay? We had real, imaginary, but actually this has turned back into real, and so now we can combine the reals together. 2 minus 4 is -2. And there's the finish of our question. -2 plus 9i. Now, the first time you do this, it seems crazy, right? We had to do a FOIL. We got all 4 parts. We had to turn this part into a real part, and then we had to combine the real parts. But once we do a second question, you're going to realize that it's very, very repetitive, okay? Doing this number considerably faster than we did the last one. 5 times 2 is 10. 5 times 3i is 15i. These two numbers would make 2i, and these two numbers would make 3i squared. Now again, a very repetitive process. The middle two are going to combine. 17i. This final number is going to get turned back into a real number because I squared is going to make it -3. We still need to keep this 10. And then, of course, these two real parts are going to combine to make 7. So it's the exact same formulaic process that we used on the last question. It looks very, very similar. We do it, we combine the middle two, we swap out the I squared, and we go from there. You guys feeling good? Any questions? Okay, cool. Number 11, I just want to make a point really quick. How do you handle anything that's squared? You have to write it twice. You cannot distribute the squared. We have to write this twice as 1 minus 2i and 1 minus 2i. Because it is squared, that means multiply it by itself. And then we go ahead and distribute, or really it's like double distributing, but we're foiling here. Actually, 1 times 1 is 1. 1 times negative 2 is negative 2i. Negative 2i times 1 is negative 2i. That would make positive 4i squared. Then this I squared, these two are going to combine and make negative 4i. Give me 1 second, Jamaris. This one's going to make minus 4, and that's going to be a 1. 1 minus 4 is going to be negative 3 minus 4i. I know I'm going super fast there, but I just want to show you guys another question. The same exact process happens every time. The middle two combine, this term gets swapped to a negative, and then we combine these two together. It's very, very repetitive once you've done a few. You got a question?
Couldn't we just foil basically the same thing, draw the arrows, and reverse the arrows?
There is a process like that. The way that I teach it, that I think most students will learn it, is to write it twice. So that's what I'm going to stick with. But you can find your own way to do it. Just make sure if you can get your way here, then you got the right answer. 12 is going to be foiling. We can handle that. 13, 14, 15. These are all pretty standard questions where we're just foiling. We should be able to handle all of these types of questions. Now, one thing that I want to talk with you guys about is if we go back to number 6, and we're going to solve number 6, the weirdest thing will happen, okay? If I just asked you guys, do me a favor, I want you to solve number 6 for me, literally half the class would foil this question. And that's totally incorrect. We do not need to foil anything. This is an addition question. And so you just need to add the two parts together, right? All you got to do is add those two together to make 7, add those two together to make 7i, and you're done, okay? One of the trickiest things about this is that we get kind of foil happy, and we start by foiling, and then we just want to foil everything, okay? Don't make yourself hard, or don't make it hard on yourself. If it says addition, just do the addition and stop when you're ahead. Okay, so be careful. To do a review really quickly, we want to keep in mind I squared equals negative 1. We want to keep that in mind so that we can make this little swap. I squared equals negative 1. All it's doing is basically taking your number and turning it negative. We also want to keep in mind that subtraction is a little tricky, okay, and that we want to make sure that we're doing 2 minus 3. Not 2 plus 3, but 2 minus 3. A lot of students will make mistakes there. And then the final little tip that I have for you is if a question looks like this, you don't have to foil it. All you have to do is add it. And so slow down a bit and making sure you're only foiling when you have to foil. All right. Other than that, that's pretty good. If you can handle those imaginary number notes and these complex number notes, you are literally 90% ready for the test. Okay, there's one tiny little thing we're going to talk about after this, but that's pretty much it. So great job today. Again, it's weird working with imaginary numbers. If you talk to your parents or guardians, they'd probably tell you that your math teacher is crazy. I never learned that when I was a kid, and they're probably right, but at the end of the day, it's easy work, so just get 100 on it and move on from there. All right, great work. See you later.